All right, peeps, let's get it going. We'll start off with number 1. But before we do, over here, if you look on the right, I put pretty much the steps on how to solve for the zeros. Again, finding the zeros, if you've seen the video already, is the same as saying find the answers or the solutions. Okay? They also will say find the roots. Those all mean the same thing. So to do that, we kind of want to use the zero product property here. So we want to make sure everything's equal to 0. Factor, step 2, you're going to factor if you need to turn it into factorings or factored form. Once you factor, set each factor equal to 0 and solve. So we've done this before, but now just slightly different direction. So let's start off with number 1. Okay? So what we want to do here is we want to make sure it's set equal to 0. So in standard form, which I have here. Okay? And then step 2, because it's not in factored form, I got to use one of my factoring methods. As a reminder, we have a bunch of factoring methods now. We have GCF, we have X, we have snowflake, and we have factor by grouping. Okay? So if you're not sure on which one to use, check out last week's Zooms, and I explain how to use these guys or when to use these guys. Okay? So in this case, we have here, we want to check for GCF. Is there something that can divide 4, 7, and 15? And the answer is no. There's nothing that can divide 4, 7, and 15. So therefore, there's not a number GCF. Then check, do I have a variable throughout? And the answer is no, there is no variable. So GCF is out the window. Now I want to check, is it one of these? So the way I could check if it's one of these guys is for these two to work, I have to have the quadratic pattern. So an even power, which I have. The next variable should have half of this power. So if this is a power of 2, this better be a power of 1, which I do have. And then the last guy should be a constant without a variable, which I do have. So that means one of these will work, and the one that's going to work is the snowflake, because we have a value that's not 1. So here a value has to equal 1. Here a value is not equal to 1. Okay, but it's the quadratic pattern. So here's our A value, B value, C value. All right. So because it's a snowflake method, I'm going to use the snowflake process. So we go A times 4, A times C, 4 times negative 15. Okay, and then my B value is negative 7. All right, and if you recall, we got to fill in the top blanks. So what we're going to do is take 4, goes here and here, so our A value goes there and there, and then we split our variable for our A value, which is r squared, so each one gets a single r. So r and r. Now we got to ask ourselves, what can multiply to negative 60 that adds up to negative 7? So this might take a while, but it's doable. So if you're good with math, this should be negative 12 times positive 5. So let's do that math. What's negative 12 times 5? Negative 60. Negative 12 plus 5, negative 7. So this is my magic pair. And now the snowflake method says this. We want to reduce this if possible. So if you look, we can reduce by 4 here. So we're going to reduce by 4. So in essence, divide by 4. 4 divided by 4, that gives me 1r. 12 divided by 4, that gives me negative 3. And we go over here. Can I reduce here? And the answer is No. All right, so once we have that, we can put it into our factors form. Remember, this is going to be equal to 0. So our factors form is 1r minus 3, or r minus 3. And the next one is 4r plus 5. So we are done with step 2. Okay, we put it into factor form. Step 3 says set each factor equal to 0 and solve. So if you look, we have 2 factors and we got to solve. So my first factor, set it equal to 0. My second factor, set it equal to 0. And now we solve for each factor. So in this case, we're going to add 3. R equals 3. Over here, we're going to subtract 5. 4r equals negative 5, and then divide by 4. R equals negative 5 over 4. So we have 2 answers. Okay? When we're finding the zeros, there's a very special part of this. The degree you have, so in this case, the highest power, which is our degree, should equal the amount of answers you get. So if it's a power of 2 here, I should get 2 answers. And you'll notice I got 2 answers because my degree is 2. If you check this, this is another way to check if you're doing it right. Okay, 2 answers, a degree of 2. All right. Cool. Let's shoot over to number 2. Okay. Step by step says I need to set it equal to 0. Right now it is not. So remember, the rule is I want to have the highest powered positive. So if you look, k to the third is highest powered. He's positive, which means everything else has to go to the left. I wanted to keep the k to the third positive, so all this stuff goes to the left. Okay? So to move stuff across the equal sign, we add or subtract it. So I'm going to add 4k squared. And what you do to one side, do to the other. So 4k squared here. So we have 7k to the third, and then plus 4k squared. They're not like terms, so we can't combine. Minus 42k equals to 24. Still not equal to 0. I still got to move the 24 over. So I'm going to subtract 24. Okay, so I have 7k to the third. And notice I'm putting it in standard form. So it's 7k to the third, then my next power is 4k squared minus 42k minus 24, all equal to 0. All right. Cool. So now, remember we have our weapons here to factor. Do I have a GCF? Can 7, 4, 42, 24 all be divided by the same thing? No. Do they all have the same variable? No. Is it a diamond or snowflake? And the answer is no. It does not have an even power. So none of these here work. My last option is factored by grouping. And how do I know it's factored by grouping? If you recall, because it has 4 terms. 1, 2, 3, 4. How does factor by grouping work? We split this guy into 2 factors. Okay? So we're going to GCF this guy. So let's pretend this guy is one problem. Can 7, 4 be divided by something? And the answer is nope. But they both share a k, and we pick the lower power one as our GCF. So our GCF for this guy is k to the second. All right, so we're going to divide by k to the second. And the answer to that is going to give me 7k plus 4. That goes in parentheses. Our GCF goes out front. All right. Why is it 7k? Because 7 divided by nothing is, or 7 divided by really a 1 here is 7. We have k3. We divide k2 out, so we're left with 1k. 4 divided by 1 is 4. K2, divide away K2, no more Ks. All right, so we got that side. Now we're going to do the same thing for the right side. We want a GCF for the right side. So how do I do that? Let's go GCF equals, so what number can divide 42 and 24? Okay, and that number is actually 6. But here's the kicker. I've told you, if you have a negative in front when you're doing this, we want our GCF to be negative. So it's going to be negative 6. That could divide, that's the biggest number that divides both of these. Okay. So do they have a variable in common? No. So my GCF is negative 6. So this gives me 7k, positive 7k, plus 4, in parentheses, negative 6 is my GCF. To know if you're doing it right, check the parentheses. They should be identical, which they are. So now I'm going to go ahead and regroup. So the GCFs go in one parentheses, k squared minus 6. And then the common factors, or the common stuff in parentheses, you just write it down once. 7k plus 4. Okay, so we factored. Now we want to set equal to 0, step 3. Okay, once we set equal to 0, we're going to solve each one. K squared minus 6 equal to 0. 7k plus 4 equal to 0. Okay, so to solve these, it's very simple. I want to get k by itself. I want to get k by itself. And if you look, what was our highest power? It was power 3. So out of these two guys, we should get 3 answers. That's the rule. So let me erase number 4 to give it a little more room. So we're going to add 6 here to get k by itself. So we got k squared equals 6. And then this is an Im1 issue. How can I solve for k? To get rid of the power of 2, I'm going to square root both sides. And k equals the square root of 6. But remember, when we're solving, square roots come with 2 answers. Square root of 6, which we don't have to do. I don't want decimal form. And also the square root, or negative square root of 6 is plus or minus square root of 6. So this guy actually came with 2 answers. Anytime you're solving and you have a square root, there's a positive answer and a positive square root and a negative square root. Since these square roots do not come out evenly, you just leave them as square roots. So those 2 answers there. Now we got to solve this guy. Negative 4, negative 4. 7k equals negative 4. Divide by 7 here. K equals negative 4 over 7. And those are my 3 answers. Okay, just be careful with again, if you're solving using a square root, you're going to have a positive square root and a negative square root like I have here. So it actually gives you two answers. All right, let's jump to number 6. If you look, they're already factored somewhat because it's multiplication, but we can factor these guys some more and solve. So same rules apply. Is it equal to 0? Yes. Is it in complete factored form? It's kind of halfway there, but we can factor this a little bit more, okay? So let's go ahead and jump into this first parentheses. I want to factor this more, and what you should notice, this guy is no GCF, but it's a diamond. Okay, here's our A, our B, and our C. A times C is 28 on top. Our B value is negative 11 on bottom. Okay, what multiplies the positive 28? That adds up to negative 11. And that's going to give you negative 7 times negative 4. Remember, when I multiply two negatives, they give me a positive. When I add two negatives, it gives me a negative. So do the math here. It works out. This first set of parentheses factors into p minus 7, p minus 4. Okay. And then we're going to go ahead and factor the next guy. So we're done with him. Let's factor him. This is my ABC pattern. Here's my A. Here's my C. We are missing my B. So when we're missing our B, we turn it into 0. So I'm going to rewrite this. This is p squared plus 0p. There's my B value, and my C value is minus 16. Okay, so remember that from last week. So this is really, again, diamond. A times C, that's negative 16. My B value is 0. What multiplies the negative 16? That adds to 0. That's going to be 4 and negative 4. Once we have that, let's put it into our parentheses. So it's going to be P plus 4, P minus 4. Okay, all equal to 0. So if you notice, these are all factored. We're done. We just now have to solve each one of them. So I set each one equal to 0. Okay, so let's solve. Add 7 to both sides. So we'll go a little faster. P equals 7 here. Add 4 to both sides. P equals 4. Subtract 4 to both sides. P equals negative 4. And then add 4 here. P equals positive 4. Only thing I want you to notice is we have a repeating answer. P equal to 4, P equal to 4. So we only really need to write it once. So it's P equal to 4 once. Okay? So those three answers would be your answer. All right. Okay, let's jump over to 9, because this one's a little bit different, but you should be able to understand it once I go through it here. Okay, so it looks complicated, and your first reaction is, oh, I'll just multiply this out twice. I'll distribute the 6, and then we can do all the work. No, you don't have to do that. There's actually, if you see the format, it's not too bad, okay? So if you look, we have something raised to the second power. Okay, then we got that same thing multiplied by 6. So what I want you to think about is this is really like x. So if I had to rewrite this, if you notice, it's really 2k plus 1. We could treat it as x squared. minus 6. Because 2k plus 1 is there again, we could treat it as 6 times x minus 27 equal to 0. Okay, we're going to treat it like x, but then once we solve, we're going to replace the x back with what it is. So think of it this way. X is really replacing 2k plus 1 for now. And once we solve for x, it's really 2k plus 1. Okay? So in essence, what I wrote here is just this guy where the 2k plus 1 is replaced by x. It makes our problem a little easier to understand. And you'll notice this is basically diamond method. Watch. Okay? Our a times c, negative 21 or negative 27. Our b value is negative 6. Okay. And what multiplies the negative 7? That adds up to negative 6. That's going to give me negative 9 and positive 3. So negative 9 times 3 is 27, or negative 27. Negative 9 plus 3 is negative 6. This is my factors form. So we put it in our factors form. Remember, this is going to be equal to 0. It's going to be x minus 9 and x plus 3. Okay, and we're just going to solve exactly how we did before. Set them equal to 0. And solve. So here we're going to add 9. X equals to 9. Here we're going to subtract 3. Okay, but remember, even though I boxed them, this is not our answer, because what is x really equal to? 2k plus 1. So instead of x, we really can rewrite it, because x was originally 2k plus 1. Now we can put it equal to 9. So in essence, I replaced the x to what originally it was in the problem, which is 2k plus 1. And now I can solve. Same thing here. This x is really 2k plus 1, because that's what it was in the original problem. And now I can solve for k. Subtract 1. 2k equals 8. Divide by 2. K in this case equals 4. Okay? Same thing here. Subtract 1. 2k equals negative 4. Divide by 2. I know I'm running out of room. And that's going to give me k equal to negative 2. All right? So that's a little trick we can use to make our problem a little bit easier, because the stuff in parentheses were exactly the same. We can replace that stuff with x, and it makes our problem a little nicer. What we can't forget once we do the process is remember, hey, our x, we got to turn it back into what it was originally, which is in this case 2k plus 1. Okay, so you get your two answers there. You'll notice this is pretty much the same idea. You just got to set it equal to 0. All right, 11 and 12. I want you to skip for now, okay? I'm going to go ahead and do these probably next Zoom, all right? Because this involves division, and we haven't covered division yet, so I want you to skip 11 and 12 for now. All right? Guys, get this factoring done. Let me give you the check-in code.